Hello everyone, this is a video lecture for Calculus 3, section 13.2, Derivatives and Unit Tangent Vectors. There's also some integrals in here also, but, well, there you go. Anyways, let's just start with some basics here. 13.2.003, and so we got R of t, let's make it official here, R of t equals 3t minus 1 t squared plus 1. And they say, hey, find r prime of t. And so, 3, you look at this, what's your derivative here? The t goes away, makes a 3, the 1 goes away. Here we got the 2 comes down, t, 1 goes to 0. Ta-da! That was it. 13.2.015. So now let's step it up. I got r of t, just r, I guess. Good enough. This is weird. Hold on. Let's rewrite this a little bit better, because this one's a strange one. I think I did this on purpose so you could see it. A component plus 2t b component plus t to the 6th power c component. Like what? And they want r prime of t. It's really not hard. Notice this is a 1 right here, so this would go away for sure. This here is going to make a 2, and that's going to make a 6t to the 5th. We just got to make sure we put it in the right format. Like I would hope that WebAssign would take this, but here's the thing, I don't know if it will. Let's assume not, just because I'm not 100% sure. But I do know we can make this thing work without having to do the vector formats. So maybe 0 and then an A component, a 2 and then a B component, and then a 6 t to the 5th C component. How do you make those A, B's, and C's? Is that you're going to use the bold button on the taskbar. So like on WebAssign, it has your math problem, and then you click on the little box and it comes out with a little tab, and there's like all these buttons and stuff. Look for one that says vectors and bold or something kind of like that, and then you would just type A, B, and C in there. Okay, so use the bold if the alligators are not working. Next one, 13.2.017. I got R of t is equal to t squared minus 4t. I got 1 plus 5t. And then I got 1/3 t cubed plus 1/2 t squared. And they're saying for sure t equals 4. They want the unit tangent vector. Let me write that out. Unit tangent vector. So what is that and how does it work? Let me give you a formula. It's a capital T of t is equal to r. It's equal to r vector prime, r prime, divided by magnitude of r prime. That's your formula. There you go. There's your formula. So it's actually not too hard. Let me show you how this works. I'm going to take my derivative, and then I'm going to have the magnitude of it. So as I go, derivative here, 2t minus 4, 5, and then the 3 comes down to make just the t squared. The 2 comes down just to make a regular t. So there's my derivative on the top. But then I need its magnitude in the bottom. And it's going to be a little bit clunky, but basically Pythagorean theorem with each one of these. 2t minus 4 squared, 5 squared, and t squared plus t all squared. This is your true unit tangent vector. But now they're wanting it specifically for at 4. So what you're doing, you're just taking that t and you're plugging it in all over the place. T equals 4. Sorry, that didn't look right for me, so I just wanted to make it stand out a bit. So you just plug in 4 all over the place and you get some easier numbers. So 8 minus 4 is going to be a 4. In the top you got a 5 still there. And then we got 4 squared plus 4, so that's 20. All over the square root of, and you don't have to do it again. You just know it's 4 squared, 5 squared, 20 squared. So the vector part, there's not much to do. You just kind of leave that alone for a minute. But There you go. But the bottom, you can at least do a little bit of math. Square root of 441, which actually, of all things, it turns out to be 21. So there's your answer. I'm pretty sure you can just type that into WebAssign. If you need to, you can individually divide by the 21, but I don't recommend starting that way. Try this, or even I'd say another one that might work, 1 over 21 times this vector. I'm pretty sure that works. I've seen this before, I'm pretty sure. Anyways, moving on. You're wanting to make it as easy for yourself to type in as possible. This one's a longer one. It has like multiple components. I got r of t is equal to 6t, 2t squared, and 4t cubed. And so first off, they want to find r prime of t. Well, this is just derivatives. That's easy. 6, 4t, 12t squared. Then they want, sorry about that, unit tangent vector at 1. So that's kind of strange. Basically, that's r prime at 1 divided by magnitude of r prime at 1. So I'm plugging in a 1 here. That would make a 6, a 4, and a 12. And to simply put it down here, you would have 6 squared, 4 squared, 12 squared. Actually, I didn't even do anything else past that. This should work here again. You could do a little bit more simplifying, but that's the idea there. Keep cruising. They want r double prime of t. So they're wanting the second derivative from here. Pretty easy. 0, 4, the 2 comes down, makes 24t. Very simple. And then finally they're wanting r prime cross r double prime. So this one's going to be a little interesting. Let me write out my 2 previous answers that I have, and then I'll do the cross product with you. It's more like a review than anything, but still good to do. So cross, and then I got 0, 4, and 24t. Okay, so let's do this cross product. Always a 0. 6 times 4 is 24, positive k component. 6 times the 24 is really big, 144. So you technically have 144t, and that's going to be a negative j component, but I'm going to put the negative in the front just so I remember a bit better. Anything times 0 is a 0, always a 0 in the middle. 4 times 24 is a big number, it's 96. And I got t squared, so I've technically got 96t squared here. Also remember that this is a positive I component right there. Positive I component. Keep going. Anything times 0 is 0. 12 times 4 is 48. But this is going to be a negative I component, so what I'd like to do instead is a negative 48t squared. If you notice there's t squared in there. I component. And then always a 0. So let me find out what that would be. All my I components here. Notice I got 96t squared minus 48t squared is going to be a positive 48t squared. My j component would just be that negative 144 t. And then my k component's just the 24. And there you go. That's your answer there. Next one. So I've got now 13,2,027. X is equal to e negative 6t cosine of 6t. Y is equal to e to the negative 6t sine of 6t. Those are t's on the inside there. And z is equal to e to the negative 6t. So that's kind of a strange thing there. They also give me this point 101, and they say find the tangent line at P. Find tangent line at P. It's kind of weird how they set this up. They have x, y, z equals an answer, like a point. Well, technically, this is x of t, y of t, z of t. You're not going to honestly just get a single number here, you know what I mean? So, okay, they want a tangent line at that point for this curve, I suppose you could say. Well, how does this all work? Well, first off, for tangent lines and stuff, you need a derivative. So we're going to take our derivatives of each one of these. So x prime, y prime, z prime. Essentially, my r prime will be, and this is going to be a product rule. This times that. So derivative of the first is going to have that -6 come down, e to -6t. And we're going to retain our cosine. Plus, I now keep my first one alone, but cosine will go to a negative sign. So let me instead change this to be a negative between them. E negative t, sine of t. Oh, it's 6t. Ooh, I almost forgot about that. Just going back up a little bit. Okay, that's a 6t, so we left it alone, that's fine. But when we take a derivative of that sign, it'll have a 6 come out to the front as well. I'm not like here bickering about derivatives, you know what I mean? I'm just trying to get it done. Keep cruising. So now I got that sign right there. Again, derivative of the first, bring the -6 down. There we go. And then derivative of sine is going to be a cosine positive, so then you could just have it positive in the front. So they're not identical, but they're really close. What's my derivative of just this guy? Well, the -6 comes down. There you go. Okay, so this is my derivatives. I want to know at what point I'm supposed to plug in this stuff. What's my t for all this here? And so what we need to do is see this point and these equations the same. I'm saying that this is x, y, z, so then this must equal a 1, this must equal 0, and this must equal a 1 in order to solve for t. And honestly, I think the easiest one to work with is this guy right here. So in order to get that 1, I'm telling you t has got to be 0. Double check it. Whenever you plug a 0 in here or a 0 in there, sine of 0 is 0, so that's going to make the whole thing go away. Cosine of 0 is a 1, making this thing here, you still got to plug in t there. Makes the whole thing a 1. So this makes sense. I'm going to use t equals 0. So thus, now, r prime at 0, I would get cosine again would be a 1. E to the 0 is going to be a 1, so -6. And then that's going to go to a 0. This goes to a 0. Again, that's going to be a +6. And then this guy's going to be a -6 in the end. So what you get is -6, 6, -6. This right here, this is r prime, sorry. This is your slopes. Remember that they're wanting a tangent line, so we're wanting to find out the slope and the intercept. And so that's what this is. Think back to y minus y1 equals m times x minus x1, right? Well, my slopes are going to be right there. In order to get my actual answer, I would take this and move it over, right? And that's kind of like your y-intercept, essentially. Kinda. It's not perfect, but that's the idea. You're going to get this guy in the end. And that's what I'm looking for in a line format. And so, here we go. I got my slopes. What are my intercepts? Well, it's not intercept necessarily because you can see these are a point that I plugged in. And we have a point. It's right here, 1, 0, 1. So this alongside 1, 0, 1 as my point for x, y, and z. We should be able to put it all in. So let me show you how it works. Here's my final answer, x, y, z. Or again, you could just do r or whatever. But my x components, I guess you can say, is that I have a -6 slope. And then I started at 1. It's kind of like an intercept. Or you can just say t equals 0 here. So as we know that, because we just tested it, so always start with that. 6t slope, and again, plus 0. And then a -6t slope, and then plus the 1. There's my final answer. Okay. If it seems a little weird how I'm making this up right here, It's just because we have to have a much more loose definition of how to do slopes and intercepts and stuff like that. Our concept is there. It's not a formula. I don't want to stress a formula. I want to stress a concept there, okay? So this is an R1 of t. It's R1 of t is 4t, t squared, t cubed. And I got R2 of t, which is sine of t, sine of 2t, and then 3t. Okay, so some things here. It says they intersect at the origin. They intersect at the origin. They want to know the angle between... Well, I didn't spell that well at all. Between the lines, between these two curves. Okay, what's the angle? So essentially I got this one going here and this one going on here, and they're intersecting, and so what's that angle that they make from right here? What's that initial angle? Obviously it would change as you keep going, but right at that point, what would I do? Well, you're going to be using tangent lines in order to find that. So you need tangent stuff. And when you think tangent, like, you should also think slope. And so we're going to basically get our slopes from these guys. So R1 prime. And again, they said origin, but what's my t value there? How can I make this at the origin? At 0, 0, 0. How can I make that happen? What's my t equal to? Definitely a 0. Same thing here, sine, and then a t. T equals 0 all day long for sure. That's what they're trying to say, t equals 0. So I'm wanting to plug in that 0 here in a minute. But let me find my derivatives first. 4, 2t, 3 comes down, 3t squared. Again, I'm plugging in 0. I'm going to say when t equals 0... Plug it in, I got a 4, a 0, and a 0. So those are my slopes for the first one. R2 prime. Again, what's my derivative of sine? It's going to be a cosine. What's my derivative of this one? It goes to a cosine, but that 2 is going to come out because of chain rule. Also, you leave the inside alone. And then you just got a 3. I still want to plug in the 0. So plugging in 0, we get a 1. It's kind of funny, you get a 2 and then a 3 right there. So these are my slopes. And I tried to go down a different road on how to figure that out after this. Went to go and do tangent stuff. That was wrong. Simply put, you just need an angle. So go back to your cosine formula. A dot B divided by magnitude of A and magnitude of B. You have an A and you have a B. So go ahead and put it in. Like, that's it. So dot product these guys. In fact, you don't need to do that. Dot product is very simple. 4 plus 0 plus 0. And then my magnitudes separately. I basically got a 4 squared. Don't need to do all that, but that's okay. And then down here, 1 squared, 2 squared, 3 squared. So I got a 4 in the top. In the bottom, this all makes a 4 just straight up. 1 plus 4 plus 9 is 14, so square root of 14. These 4's obviously cancel, so we're looking at this guy. So my angle should be the arc cosine of 1 over square root 14, which, if you go into your calculator, 74.4986 degrees. Again, remember to make sure you're in degree mode to do that. Excellent. So now let's do some integrals. So I got 13,2037 integral 0 to 2 of, and I'm going to write this out the way they do it, 6t I component minus t cubed j component plus 2t cubed k component dt. So honestly, I like to think of this as a vector, but you know, that they write it this way, that's fine. Let's find the integrals. Very easy to find integrals here. So I got 6t squared over 2. Here I've got negative, make it a little bit better looking. negative t to the fourth over 4. And then here we got 2t to the fourth over 4. And I'm going from 0 to 2. Just plugging them in, right? So that's obviously a 3. There you can have a divide by 2. Whenever you plug in the 0, everything goes away. But the 2 you can plug in. So I got here 3 times 4. I have this one. I think it would just be a negative 4 total. And then yet again, I have, they cancel to, I think that's going to be an 8. So there's my final answer, 12, negative 4, and 8. There you go. Moving on. 13.2.023. I got integral of, and I'm going to write it with my notation, secant squared t times t squared plus 1 squared, and then finally t to the 6, not squared, t to the 6 ln of t. Now if it's been a while when you're doing basic integrals like this, just watch out. So first off, my integral of secant squared is definitely going to be a tangent t. That's easy. This here is going to be a u substitution. du 2t dt. So dt is du over 2t. And then you can see what's happened to the t's are going to cancel, leaves a 1/2 behind. So this one's going to be a 1/2. And then my original now cubed. And then divide by 3. Okay. And then blah, 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 blah for this guy. I ran out of a little bit room. Well, this one's not as easy as the other ones. We're going to have to figure that one out. So I'm saying integral of t to the 6 ln t dt. Like, what is that guy? And it's going to be integration by parts. So I'm going to do u is equal to ln t du. My derivative of that is going to be 1 over t dt. And then I got dv is going to be that t to the 6th dt. Looking a little sloppy there. And so v, when I integrate that, should be t to the 7th over 7. This right here, that ln into 1 over t, it confused me. I actually flipped all this and I did it wrong the first time. Just watch out, because it's been a while maybe since you've done it. It's been a while for me maybe. So just make sure to know, your basic rules. Derivative ln is 1 over that stuff, etc. And so your formula is uv minus integral v du. And so that should be my answer here. Here we go. I got 1/7 t to the 7th ln t minus integral of 1/7 t to the 7th times 1 over t dt. What happens is that 1/7 can come to the front. These t's cancel just a tiny bit. Go ahead and rewrite it a little bit. This is t to the 6th now. And then I can integrate that guy. To be t to the 7th over 7. Oh, no more need for that. I guess you can have a plus c by this point. Anyways, so you can see that I got a 7 and 7 makes a 49 in the end. So I got 1 over 49, t to the 7th. Okay, phew. All right, so final answer. What does it look like? It's a vector. Tangent t 1/6. If you go way back up here, I had 1/2 and a 3 together make a 6th, by the way. Now it's cubed. And then finally, all this stuff. 1/7 t to the 7th ln t minus 1 over 49 t to the 7th. And this all is your answer, and they have a plus c on the outside. Notice that it's a c vector. It's already there in this problem, but sometimes it might not be, so you got to watch out, okay? C vector is essentially saying C1, C2, C3, depending on your X, Y, and Z stuff, okay? So it's required for literally every component, but C vector kind of basically just takes care of all that for you. So that's nice of that. One last question. 13.2.051. So It says that I got f prime of 2 is what I'm looking for. And they give me that f of t is equal to u of t dot v of t. They also give me some other stuff, so let me start listing that out. U of 2 is equal to 2, 1, negative 2. Whoa. Hold on. U prime at 2 is equal to 319. They give this stuff to you. V of t is equal to t squared, t cubed. And from here, we can find t prime pretty easy. 1, 2t, 3t squared. And so thus, from both of these, I can find v of 2. When I plug it all in, I got a 2, a 4, and an 8. V prime at 2. Again, just plugging into 2 because they got 2's all over the place apparently. A 1, a 4, and a 12. Phew, so what are we using all this stuff for? So they said that it was originally u dot v for my f, right? So f prime, how does it work? Well, it's kind of like product rule. I got u prime dot v plus u dot v prime. It's kind of like product rule in that. So it's not like a new formula for us. It's just kind of different looking. And I have all of these vectors, so they're all up here. Let's start plugging them all in. I got 319 dot. My original was a 248 plus. Oops, that's a vector there. U is a 2, 1, negative 2. Oops, dot. And then my v prime is a 1, 4, 12. Okay. Doing the math here, we got a 6 plus a 4. 8 times 9 is 72. No, maybe I did something wrong here right quick. Because I wrote something different. Hold on. U prime? Oh, yeah. Yeah, I did. Did y'all see that I messed up right here? I flipped these. I did, this was u prime and this was u. No, I did it right. Never mind. On my paper, on the formula, I flipped it. So I didn't have this. I basically just changed them. 2 plus 3 is 3 plus 2. So never mind me. This is great. Everything's fine. Keep moving. So over here, 2 plus 4, and then minus 24. You put all that stuff together, and you get 64, and you're finally done. Okay, that's it. Thank you very much. Have a great day.